Thank you, Alan. So I'm going to do a little bit different to my normal talks that I've given in the past at TAD Summit. I've focused more on voice and video and WebRTC. Today I'm going to look more on the network side and follow on from some of the stuff that James was saying, and then we heard from Patrice earlier this morning. And I'm going to particularly look at enterprise wireless networks. And I'm going to disagree with the introduction from Alan yesterday, where Alan said, developers no longer need to think about the network, they can focus on the services. I like to think, well, maybe they don't need to focus on the network, but actually it's getting cheaper and easier for them to actually do the network and build the network if they want to, and they want to create a custom network. And actually it might not even be about services. It might be about owning and operating infrastructure rather than paying a service provider. So there's still going to be interesting opportunities for new classes of SP, but I want to give a little bit more of a color on some of the things I see coming around the private cellular, also Wi-Fi, some stuff on spectrum and policy and so on as well. So who am I? If you don't know who I am, my Twitter handle is Disruptive Dean, and I tend to like to disagree with people. Not always. Sometimes I agree with them violently as well as disagree with them. Occasionally I'm wrong. I try and keep those instances to a minimum. And so I look at networks, I look at voice, video, messaging, communications, applications and services, and I do this sort of cool bucket of stuff that I call telecom futurism, which gives me an excuse to go and talk about artificial intelligence and blockchain and AR and VR and all the sort of cool stuff, quantum computing and so on. Which at the moment people don't pay me as much for, apart from the blockchain stuff, which actually is quite interesting and a bit more near term. So, pretty picture of wind turbines. One thing you'll notice is, first is they're very big. Second thing is there's lots of them. And the third is they're in the middle of nowhere, which means there's probably no cellular network coverage. And they're probably too big and too dispersed to have a decent Wi-Fi coverage either. Obviously, they're fixed, so there's probably quite a lot of the control stuff is going to be coming from fiber to connect directly to the motors. But imagine you want to do a drone inspection of the outside to check that there's no faults, there's no rust, if there's metallic materials and so on. You would need to have good wireless connectivity one way or another to be able to do an inspection, even more so if this was offshore in the sea. And so there's a need for better on-site connectivity here, whether it's a drone, whether it's additional sensors that are being put around, who knows. Another industrial use case could be in the oil and gas industry. In fact, I know this company, Vopak, and they basically operate these gigantic storage tanks for oil, gas, chemicals, all sorts of things in different places around the world. And they were saying that actually, you see the stairs that go up the side of the tank? They have to send someone up every day to check how much is in the tank because they're not automated historically. And it takes about half an hour for the guy to get up and down the stairs, sometimes longer. And if you think they might have 10 or 20 of these tanks on one site, realistically, the time you've got entering all the records and data, it probably only sees each one twice a week. And it's not an easy thing, again, to put wireless networks on because, firstly, it's quite a long way above the ground. Secondly, if you want to sort of put any form of electronics or electrical machinery there, or device, you have to take into account the fact that it's explosive liquefied natural gas, which means the number of certifications and bits of paperwork you need to do with anything at all is quite significant. So what they would love to do is have fairly simple sensors that are depth detectors for liquefied natural gas, which sort of pinged, could be once an hour, could be once every half an hour, could even be once a day, just so they get an easier readout. So this is the sort of diversity of things you see in IoT and some of the challenges for collecting the data. And there's obviously a lot of, if you like, applications behind the scenes that would use this to improve performance, maintenance. If you did predictive maintenance on all the world's machines and you fixed them before they went wrong, rather than after, you could probably add 2 or 3% to GDP, global GDP. Now, you often see charts talking about wireless technologies that usually plot, I don't know, speed versus range, or something like that. And that's all very nice, and it's sort of quite cute two-dimensional representations of what's actually a much, much more complex problem. And the problem is that there's probably 5, 6, maybe even 10 different dimensions. And I can't really display a 10D hypercube, unfortunately, on this projector. And I probably couldn't get my head around it, even if I could. But you've got things like the range, you've got what's the source of power. Do you need battery power? Can you plug it into the mains? Can you harvest energy from piezoelectricity or something? How important is your application? Is it something which is nice to have? Is it business critical? Or is it safety critical, where actually there's people's lives that depend on it not going wrong? And depending on where they are, you have different requirements for the radio, different requirements for who runs it, the security, and also whether you're willing to trust it to unlicensed spectrum, the sort we use for Wi-Fi, or whether you want to have that radio protected by licenses and law of one form or another. And the further it gets towards safety critical, the more it is important to have some sort of guarantees about spectrum availability. A good example is if you ask someone whether they would be prepared to be operated on by a surgical robot connected with Wi-Fi, the answer is not usually a very positive one, even from Wi-Fi. I asked that at a Wi-Fi conference a couple of weeks ago. I think I had one person put their hand up and said yes. And then you have coverage, which could be, do you need to cover absolutely everywhere down to the last cubic centimetre of space if you have sensors in an oil refinery? And there's also what I had there is 3D, whereas if you actually have drones or tall infrastructure like the tanks, you actually need to think about how deep is the coverage. It's not just square meters, it's actually cubic meters up to, let's say, a height of 300 meters for aerial operations. So in a nutshell, what this says is there is no one magic technology or even a family of magic technologies. It's not all 5G. I'll talk about 5G later on. There will be multiple radio networks needed with multiple people owning them and lots of software and developers thinking about this stuff because it's going to be important, complicated, and there's going to be business models and revenue and profitability and productivity associated with it. And it's not just about the IoT. I mean, even within IoT, there's lots of things. There's things that move. There's things that are stationary. There's always going to be an office building somewhere with lots of people in it. You might find that the site is owned by one company, but it has contractors there, tenants. So it could be a shopping mall with different brands in it. It could be an airport where the food, the catering, and the luggage is done by third parties. All of this is complicated. And then there's going to be additional rules for security, public safety. Obviously, if there's an emergency, the radios need to work, or perhaps people want to replace the radios with the traditional walkie-talkies with some form of cellular. That needs to have high availability and guarantees as well. And then you might have guests and visitors on site. So all of that complicates matters and again means that there's a lot more that needs to be done in software to run the network and actually to provide the capabilities. I'm using the word capability rather than service here because some of this may be offered as a build service and some might just be operated in-house or provided as a community. And each industry is different. They all have separate requirements and lots of expertise. So in manufacturing, I didn't realize this, but welding machines blast out tons of radio interference. And so you need to work around that. Some industries, obviously, you have explosives, like the mining industry. Electricity was an interesting one. I heard a presentation from someone from one of the European electricity companies who was saying, we can't really use normal 4G or even 5G networks to run the high voltage grid, particularly because it's going to get more complicated in future with solar panels, with storage and batteries everywhere. He said, well, the thing is, if we ran it on a cellular network provided by an operator, their cell towers run on our electricity. So unless you have diesel backup everywhere, if one goes down, the other will go down, and we can't get it back up again. So therefore, we'd like to run our own network. And every single industry has its own sort of special, please, we need to do this differently argument. In some cases, they want to have their own spectrum. In some cases, it'll need a partnership or an integrator or an outsourcer, or perhaps a telco with a specialist unit. And it's not just industrial. I don't have time to go through all this, but it could be, I don't know, shared office space like WeWork and Regus. It could be sports stadia, hotels. You know, why don't we have in the DoubleTree hotels free roaming if you are on AT&T, provided in the hotel, or something like that. Yeah, there's a lot of things you could do, or you could provide. Well, actually, it's not bad down here, but you know, coverage indoors is always a challenge. There's a ton of wireless networks around. And I'm not going to go through all of these, but you know, there are ones which are good for mobility. There's ones which are good for low power and battery life. Some of them are cellular versions, so 4G and 5G. There's low power versions of LTE called LTE Cat-M and NB-IoT. There's private networks running on a technology called LoRa. There's another low power one called Sigfox. In fact, I saw a demo from Sigfox recently. They want to do 20-cent disposable radio wide area chips, like RFID tags. They showed a demo on a stage where they had what looked like, I think it was a FedEx envelope. And when you open the envelope, there's a one-use tag inside it that basically does a timestamp, a GPS stamp, and a "I've been opened" message to the network. And for 20 cents, there's plenty of people who will pay for that. So yeah, there's going to be a lot of different choices for networks, depending whether it's a traditional MNO, what I'll call a non-MNO service provider, and I'll come back to that, or private and government use, depending on all these different parameters. On top of this, there's a bunch of questions about edge computing. And you will hear, I've already heard the term edge computing used a lot today. I would say I've come across at least 5 different definitions of edge in recent months. Everyone has a different view. So if you ask a lot of people in the cellular industry, the idea is, oh, we're going to have an edge compute server in the network that can offer millisecond latency to passing cars for applications. But then if you speak to GE, they'll say, well, to be honest, we've got 1,000 sensors in a jet engine, and half the time it's at 12,000 meters altitude, where, frankly, we need to have an edge box that deals with all the sensors, collects a terabyte of data per flight, and then when you get down to the airport, it then decides which 10 gig to upload and what to keep for the next maintenance cycle. And then you have the sort of Amazon and IT view of edge as well, and these sort of meet in the middle, but not quite. So, who's doing all this? The moment, if you ask most people about spectrum, I realize this audience is more of a software one, so I'm not going to go into this in the policy angles of it, is why do people buy chunks of spectrum? Mostly it's to run mobile phones. And you have different bands. A typical mobile operator will have 3, 4, 5 different bits of spectrum, some with better range, some with more capacity, some that go indoors better. But normally, there will be national licenses, and you know, they're mostly aimed at traditional machine-to-machine or phones. And they're pretty much sort of undifferentiated. Then there's a few organizations that also have national licenses, like maybe a utility company, railways, public safety, government as well. But there's only so much spectrum that is available, and only and that is usable frequency ranges, and we're running out of easily easy parcels of spectrum to give to people for these sorts of application that can be completely dedicated to one provider, because there's lots of existing uses of network spectrum that could be military radars, it could be TV broadcast, it could be satellite, it could be point-to-point links for microwaves between government buildings or something like that. And it's really hard to clear new bands, so anything that's new has to work around the incumbent users. So there's a few new models. We heard earlier on this term CBRS, which is a US concept for spectrum sharing. And there are varying other attempts in Europe and elsewhere in Asia to come up with chunks of spectrum and mechanisms to allow different people to access it, still with a degree of reliability and protection. And there's another approach, which is I've referred to a couple of times today, because Multifier is running LTE networks in the same bands as Wi-Fi. And that's also starting to become real. And over the next 12 months, we'll see a lot more CBRS in the US, Multifier globally, and then some other interesting shared or local spectrum propositions. So in the Netherlands, it's already possible for some industrial companies to get dedicated chunks of spectrum to run private networks. What's the mobile industry doing? Well, to be honest, an awful lot of the mobile industry is deeply focused on 5G at the moment, and is also trying to convince governments and regulators that 5G will do absolutely everything everywhere. It won't, and it certainly won't do it all immediately. So you'll often see this three-bubble diagram or a triangle that says there's three uses for 5G: enhanced mobile broadband, which is basically faster smartphone data, massive IoT, where you've got millions of sensors per square kilometre, and then ultra-low latency, which is millisecond latency for autonomous vehicles. No, that's not a use case. Maybe robots. There's an awful lot of, frankly, total bullshit that's talked about this. What's actually going to happen is there's a fourth bubble called fixed wireless that will use 5G in the US and South Korea first, probably. Then you'll have the smartphone use case, likely in little islands. So you'll find that the center of a city or a shopping mall, here and there, will get 5G, and over time, those islands will grow. Maybe South Korea or Japan will replace everything else faster. And then the IoT use cases that the developers would want to exploit are actually a long way out. So if you speak to a developer who's actually looking at self-driving cars, their focus is on making the car able to be fully autonomous. And it will be able to have the sensors locally, the compute locally, and it will use the network for updates to the algorithm or to upload the data at the end of the day. Maybe it'll have a secondary feature to allow the network to show it what's happening around the next corner with a video camera, but that's secondary. Yeah, autonomous vehicles will have to be autonomous. And so you have an interesting set of challenges for developers here, where they have to think about all of these different network possibilities, but not necessarily rely on them, and use them where they can, but also expect that sometimes there will be no coverage. So what this tells me is that the traditional national mobile operators are not best suited to this. They will have limits on their coverage. They're obviously can't be an expert in all of these verticals and all of these areas. They also face challenges around data sovereignty, lots of liability issues. Are they going to want to insure the surgical robot for €30 a month of connectivity? Probably not. Regulatory issues in various areas. I think there's some stuff we can talk about network slicing might come up in the questions. So there's lots of organizations that will need to think about network development and operations, whether it's governments, venue owners, the community type of a neutral host model we heard from James earlier on, industrial players, solution integrators, big companies that like ABB and GE that make industrial systems and process controls. And a lot of these don't really have telecoms expertise or network expertise. And they will have to suddenly, some of this they will outsource, and again, a set of opportunities here. They will have to think about not just the network and the radio, but they'll have to think about what do we do with the old walkie-talkies? What do we do with the people wanting voice applications on site? Maybe who have an AR headset. They're doing maintenance operations, high bandwidth video, one direction, and then someone else talking in their ear saying, unscrew this bit, tighten that. The network side of it, there's the billing and operating and OSS systems, roaming and interconnect, and then what do you do about numbers? What's the number for the sensor on the top of the oil tank? Who knows? Is it going to be provision an eSIM using remote provisioning? Possibly. So there's lots of moving parts here that need to be thought about. So to sum up, IoT in particular, but also localized networks are going to be really important in lots of industries. There's a lot of different ways the networks will get used and a lot of different levels of importance. Some will need new approaches to spectrum. There's going to be a variety of approaches around services, ownership and control. Bits of it will be outsourced. And there's a lot of opportunity here for the wider telecom developer opportunity. That's not just thinking about the communications applications and services, but about the infrastructure and the security itself. And there's a ton of other issues this means in terms of sort of government policy and skills and training. So don't underestimate the complexity, there's something there. And last, a very small plug. I'm running an event, a workshop on private and enterprise cellular on the 1st of December in January. If anyone wants to talk to me, ask me over coffee. Thank you.
And it's on your weblog as well for further details.
Thank you.
Excellent, that was great. Thank you so much, Dean.